neighbors. Today we're going to be talking about limits at infinity and infinite limits.
Right now we will be looking at vertical asymptotes, and as the independent variable x approaches a finite number, the dependent variable y becomes arbitrarily large or small. The problem we will be looking at is 3x squared minus 48 divided by x minus 4. Then we will apply the limit as x approaches 4, because if we plug in the 4, it goes to 0. And then we factor the top, and here we cancel out, and we're left with the limit as x approaches 4 is 3 times x plus 4, and that equals negative 24. And we do not have a vertical asymptote. We have a hole in the graph at 4, negative 24, since our x value is 4, and when we plug in, we get negative 24. And if the bottom does not cancel, we have a vertical asymptote, and this is our example of 1 over x minus 4, vertical asymptote at x equals.
Clean as a whistle.
That's 1 star.
It's clean. It's neat. I'm ready whenever you are.
Oh, all right. Well, the definition of limits at infinity is as the independent variable x approaches an arbitrarily large or small number, the dependent variable y approaches a finite number. So basically, as x approaches infinity, y will approach some finite number. So in the midst of all this, you want to keep in mind number sense. You want to make sure that when you plug in infinity, it makes sense, number sense. I guess that's what that means. But so we're going to use the example f of x equals 4x squared plus 3x minus 2 divided by x squared plus 2. So when you're writing the limit as x approaches infinity, if you plug in infinity to x, you're going to get infinity over infinity, and that's not what you want, because you want a finite number, not an infinite number. So you want to look at the degree of the variable on the numerator, and what you're going to do is you're going to divide every term by that degree. So in this case we have x squared. That's going to be what we're going to divide everything by. So you divide everything by x squared, and when this cancels out, this is going to end up being 3 over x. Then you plug in infinity, and that's going to be 3 over infinity, which is essentially 0. So both terms are going to end up being 0 on top. And then you look on bottom, this is going to go to 1, and that's also going to go to 0, since 2 over infinity squared essentially is irrelevant. So then you're left with 4 over 1. And notice whenever you go to plug in actual numbers, you don't have to carry down infinity, the limit as x approaches infinity. So then you just simplify and you get 4. But you always have to check them from both sides. So you come over here to approach infinity from the negative side, or approach negative infinity, sorry. So you have the same equation, you do the same sort of thing. It's all worked out the same, except you can tell right here, I actually forgot to finish writing this. I would have gotten points off for that. Thank goodness Jay Weese made it clear to do that. So then you end up getting the same number, but you want to check to see if it's positive or negative. So you plug in negative infinity to right here. So negative infinity squared is going to be positive infinity. So that's how you use your number sense. If that was x to the third and you plugged in negative infinity, then it would be a negative 4, but it's not.